We're going to be graphing quadratic equations right now, and we're going to start with the simplest one, and that is the parent function of parabolas, and that would be y equals x squared. So, because we don't really know anything else about graphing quadratics, we're going to start by just creating an xy table. And that'll allow us to just generate points. So if I plug in, let's just start with 0. If we plug in 0 for x, 0 squared is 0, so we get 0 for y. So our first point is 0, 0. So we'll plot that here. And there we go. Okay. If we plug in 1 for x, so if we plug in 1 right there, 1 squared is 1, so the output would be 1. So that point, we'll plot that, 1, 1, right there. Okay. And then, if we plug in 2 for x, so now this is 2. 2 squared is 4. So that now, we'll plot that to 4, that's right here. Let's go the other direction, and so let's put in, let me extend this down, put in -1. If we plug in -1 here and square it, -1 squared is +1. So now I've got a point -1, 1. That's here. So now we're starting to see the general shape of our of all of our solutions. And so we'll plug in one more, -2. And when we get that, -2 squared is 4. So this is going to be right here. Now you can see if I did put another one in, let's say we put 3 in here. If I square 3, I get 9. So you can see that that's off of our our coordinate plane. Here it's way up here somewhere. This function, it blows up pretty quickly. Everything's just going to keep getting higher faster as we go, as our x's get larger. So if we draw the general shape of this, it looks something like that. And that's our parabola. Now we want to look at this parabola, and let's just kind of look at the way it is. And so there's one point in particular that's significant, and that is this one here. We call this one the vertex. And then you'll also notice that on either side of the vertex, you kind of have this symmetry that's occurring. And really, there is an axis of symmetry that occurs right down the middle of the parabola. In this case, it's along the y-axis, just because of the placement of the graph. And this is our axis of symmetry. Axis of symmetry. All right, and that means that you'll notice that there's this point here, and then at the exact same location on the opposite side of the axis of symmetry is another point. Same thing here. So it's 2 away, 1, 2, and then 1, 2. We have another point. And so there's just a mirror of this side here is a mirror of this side. So those are two things that we need to be familiar with. Vertex, axis of symmetry. I almost forgot to label the parabola. This is the parabola right here. Parabola. So the actual graph, the shape of that is called a parabola. Okay, a couple of things. This will be real quick. If we were to graph this equation, the shape of this would look something like this. So that's kind of the shape of this one. And then if we graphed the other one, this one here, it's going to look, oops, forgot my arrows here. It's going to look something like this. Okay, and what you notice right away is this one opens up, right? So if you dumped water in here, it would hold water. And this one opens down, and so if you put water in it, water would fall out. The easiest way to figure out if it opens up like this or if it opens down is by looking at the leading coefficient. The leading coefficient is the coefficient that's attached to the x squared. And if it's positive, it's going to open up. If it's negative, it's going to open down. Simple as that. Okay, so that's one thing to keep in mind. If your a, or leading coefficient here, is positive, opens up, negative, opens down. All right, so if we wanted to find the axis of symmetry, so far we have, we've got what we can determine if it opens up or opens down just by looking at the sign on this A here. Now we're going to find out how to determine the equation of the axis of symmetry, okay? And then what we'll do from there is we'll get, using the axis of symmetry, we can get the vertex, the coordinates for the vertex. So those are two important things when you're graphing a parabola. So the equation for the axis of symmetry for an equation like this is x equals negative b over 2a. Pretty simple. This we can get this or derive this using calculus. I'm not going to show it because we don't know calculus, but we can. That's one way to get it. So for now, we're just going to go with it. We're going to say, all right, we know the axis of symmetry. This is the equation. It's x equals negative b over 2a. Notice that it's x equals. So when we graph parabolas from this equation, their axis of symmetry is going to be vertical. And vertical lines have equations like x equals negative b over 2a, where it starts with x like that. Okay, so let's do an example and find the axis of symmetry. Or actually, let's come up with how to get the vertex. Once you get this axis of symmetry here, then the vertex, which is this point right here, right on the axis of symmetry, we would know the x value of that would be negative b over 2a. We would just need to figure out the y value, and we can get the y value by plugging in this into our equation here for x. We'll just plug in the x value, and then it'll tell us what the y value is, and I'll show an example of that right now. All right, so we are going to do three things here. We've got an equation here, and we're going to determine if the graph of the solutions for this equation, if up or down, we're going to determine the axis of symmetry, and then we're going to determine the vertex. So the first part, determining if it opens up or down, this coefficient is 1, and it's positive 1, and since it's positive, it opens up. So we already did part 1. That one's done. Part 2, axis of symmetry. Axis of symmetry, remember the equation is x equals negative b over 2a. So we have b is 10, a is 1, so we'll plug those in. We get negative 10 over 2 times 1. So this is negative 10 divided by 2 is negative 5. So x equals negative 5. So that is our axis of symmetry. Okay, so if we were graphing this, we would know that where x is equal to negative 5, 2, 3, 4, 5, which is out here, we would have an axis of symmetry right here, like that. And then our parabola opens up, so we know that the vertex is going to be somewhere along this line, and it's going to open up, something like that. Okay, so we've got our axis of symmetry right here. Now, let's get the vertex. And all we have to do to get the vertex is we take this value and we plug it in for x up here and find out what y is. So we get y equals x squared, negative 5 squared plus 10 times negative 5 plus 25. So y equals, this is going to be 25 plus negative 50, and then plus 25. So y equals, in this case, it equals 0. So what we have is a vertex of -5, 0. So that's our vertex. This is our axis of symmetry, and if we were to graph the vertex, it would be at -5, 0, which is right here on the x-axis. So we know that this parabola is going to look something like this. We just don't have it, we don't know exactly where the points are because we haven't done the calculating. Oh gosh, that looks terrible. How do I get rid of this? Oh, there we go. There, looks like that. The little toolbar on the left kind of covered up when I try to draw that left-hand side of that parabola. Anyway, all right, you get the idea. So that's whether it opens up or down, axis of symmetry, and vertex. All right, so the process is the same for all of these, determining opening up or down. Is this positive or negative? Here's your axis of symmetry, and here's how you do your vertex right here. So we're going to leave it here, and this will be the first part. This is part 1, just finding the axis of symmetry, finding the vertex, and determining if it opens up or down. Next, we'll actually figure out how to graph these things, and that'll be it. So that'll be part 2. So that's the end of this video.